We're back. Part 2. Let's quickly finish this up and then we'll play with the unit circle. So this is the reciprocal function. Let's flip this. This would be negative 7 over 2 on the square root of 6. That will need to be rationalized. This would be negative 2 on the square root of 6 cotangent over 5. So the only two that need to be rationalized are secant and tangent. And let's try to do that in our head. This would need to be multiplied by square root of 6 over 6. So that would give us a negative 5 on the square root of 6 over 2 times the square root of 6 times the square root of 6, which would be 2 times 6, which would give you 12. This one, multiplied by square root of 6 over square root of 6. So I'm going to have a negative 7 on the square root of 6 in my numerator, divided by 2 times the square root of 6 times the square root of 6. 2 times 6, 12. Now, for the rest of the video, I would like you to have a unit circle. That's going to be the next part. And I'm going to get one. We are going to fill it out together, and I'm going to explain why the numbers and the values are where they are. So this part of your notes is just to have a completed unit circle. If you are perfectly confident right now in your unit circle ability, then you can just fill out the unit circle and then check it. I am going to go through the unit circle for the rest of this, so you need to get your blank one and let's start to fill it out. So here's a blank unit circle, and you will have to complete one of these for a quiz. It will look just like this, and you'll have an allotted amount of time to complete it. The first thing I'd like to take us through is to do the quadrantal angles. We know those very, very easily. So remember, we started at 0, we went all the way around, we were at 360 degrees. That also was 0 or 2 pi if we did radian values. Let's go up here. This was 90 degrees. That was also our pi over 2, remember? All the way over here, halfway around the circle, was pi, or 180 degrees. We went 3/4 of the way around. We were 3 pi over 2, or 270. Remember, we talked about that when we were doing the angles before. So those should be pretty easy. Let's also do the points while we have those 4 areas. This would be 1, 0. This is 0, 1. The cosine sine. This is a negative 1, 0. And down here at 270, you have 0, negative 1. So those are pretty easy to do initially. The next thing I'd like you to look at would be the 45 degree angles. So when you split it up with the 45s, okay, you have something that looks like this when you're going halfway. So let's look at the 45s. That would make this 45 degrees. Another quarter would get you to 90 degrees. 45 plus 45 is 90. Add another 45. That gets you to 135. And then you add another 45. That gets you to 180. Remember, we said that this was pi over 4. That's a quarter of this whole distance right here. 1 whole pi, that's a quarter of the pi. This would be 2/4 of the pi, or half. This would be 3/4 of the pi. And then 4/4 of the pi would be the whole thing. That would be pi. Okay, let's still go by fourths. If I'm at 4/4 here, the next one would be at 5/4. And this would be at 6/4, which is the same thing as 3 over 2. Then we would be at 7 pi fourths. And then the last one, 8 pi over 4, which is 2 pi. So that worked. Let's go back and get these degrees. This is 135, this is 180. Add 45 degrees and you're at 225. Add 45 degrees and you're at 270. Add 45 degrees and you're at 315. Yes, you will have to do this math and memorize these without the calculator. You can do that. Now let's talk about the other angles. Now this continues still looking at this first, at the half. If I come up here to this first line, that is 30 degrees. I'm going to switch colors because now we're going to play with the other angles. If you come up 30 degrees, the 30-degree mark splits your circle into this many pieces. All right, 30, 30, 30, 30, 30, 30. It's splitting it into sixths and into a whole pie into sixths. So the first part is 30 degrees, or pi over 6. If you see how that is a whole 180, if I divide that by 6, I get 30 degrees, but I have split the pi into sixths. So this is at pi over 6 at 30 degrees. Let's do the degrees. So if I'm at 30 degrees, I go another 30, I'm at 60 degrees. Then if I add another 30, I'm at 90. If I add another 30, I'm at 120. If I add another 30, I'm at 150. If I add 30, I'm at 180. So far, so good. Add another 30, you're at 210. Add another 30, you're at 240. Another 30, you're at 270. That's good. Another 30 puts you at an even 300. Another 30 would put you at 330. And another 30 at 360. So that got us all the way around going by 30s. Now let's divide it up. Remember we said each wedge was a sixth of the pi. So this is 1/6. This would be 2/6. Well, think in your mind, if you have 2/6 pi, okay, 2 pi over 6, that's really equal to pi over 3. Now let's go, this would be 3/6, which is a half. This would be 4/6, which is 2 pi over 3. This would be 5 pi over 6. This would be 6 pi over 6, which is at pi. Now I'm 6 pi over 6. This is 7 pi over 6. The next one would be 8 pi over 6, which reduces to 4 pi over 3. Then 9 pi over 6, which reduces to 3/2. Then 10 pi over 6, which reduces to 5 pi over 3. And then 11 pi over 6, which reduces, it doesn't reduce, but then you have 12 pi over 6, which reduces to 2 pi. Now I want you to notice something. We have done all the interior angles and radian values. We will now do the outside points, but let's look at some patterns first before we move on. If you will notice that my 6's, my radian values, it's like a bow tie. Let me see where that paper is. Here, for the 30-degree angles, okay, I have bow ties here. It's a big bow tie, and I can make these right triangles. If I look at this triangle, that is a 30, 60, 90 triangle. And when I look at that particular triangle, we played with those earlier, and you've played with them in geometry. When you have a 30, 60, 90, you can make that. Let's just look at this for a minute. If you have a 30, 60, 30 degrees right here, remember from geometry how one side, the side opposite the 30 degrees was x, and the hypotenuse was 2x, and the adjacent side was square root of 3x. Well, this is a unit circle. That means my radius is 1 unit. So if I have 2x equal to 1, then x is equal to 1/2. That makes my y value 1/2 right here. If x is 1/2, then this adjacent side would be square root of 3 over 2. So that makes this my x this my y value for this point. I can set that right there on that triangle. And that gives me the coordinate for this. I have come over square root of 3 over 2. I have gone up 1/2. Right there. Now, let's look at your bow tie here. If this is square root of 3 over 2, this x value is also square root of 3 over 2. Positive. This x value would be negative square root of 3 over 2 and negative square root of 3 over 2. Remember, our x's would be negative here, positive here, but let's look at the y's. This would be a positive 1/2. My sign value here is also positive 1/2. Down here, they're both negative. It would be negative 1/2. So let's go ahead and write those values in on our triangle. Let me get a different color here, on our circle. So this would be square root of 3 over 2, positive 1/2. They're both positive in quadrant 1. Down here in quadrant, let's come down and do this one. This would be also the x is positive, square root of 3 over 2, but my y, remember, is negative 1/2. Come over here. This has the negative x, remember, so it's negative square root of 3 over 2. This has a positive 1/2, and in quadrant 3, they are both negative. Let's look at the 45-degree angles. The 45-degree angles are going to be the same. Remember that one, if you look at this triangle, we have 45, 45, 90. Both sides were x, and the hypotenuse was square root of 2 times x. Again, if you let that equal 1 and you rationalize it, x equals the square root of 2 over 2. So those are pretty easy. On all the 45s, you're going to have square root of 2 over 2, square root of 2 over 2. Down here in quadrant 4, square root of 2 over 2, square root of 2 over 2. But the sign value, the y's, are negative. Come over here to quadrant 2. Square root of 2 over 2, square root of 2 over 2. But I'm in quadrant 2, so my x's, my cosine is negative. Down here in quadrant 3, at 225 degrees, square root of 2 over 2, square root of 2 over 2, everything's negative. Negative x, negative y, negative cosine, negative sine. One more. 60 degrees does the same 60, 90 triangle, but this time, 30, 60, 90, this time it's turned on its edge. This time, if you notice, opposite the 30-degree angle, because the interior is the 60, this is your x. So you still have the hypotenuse that was 2x. That's still the unit circle, that's still 1, but that makes this x 1/2. And the y, the square root of 3 over 2. So these are flipped. Here my x is 1/2. This is the square root of 3 over 2 for the y. Likewise, come over here. See, same y value. The y value is the same, square root of 3 over 2, but your x value is flipped. It is negative 1/2. Let's do the ones down at the bottom. This has the same x, same 1/2, but my y value is negative, square root of 3 over 2. Last one, both negative. Negative 1/2, negative square root of 3 over 2. There are some cute little patterns that people will teach you. You can get on the internet, find all sorts of different ways to do this. You can remember different tricks. Notice that the points are all divided by 2 within each quadrant. You can count look at the numerators. Square root of 1, square root of 2, square root of 3, square root of 1, square root of 2, square root of 3. All different kinds of little patterns. I prefer to remember that this x value right here, this x for that point, is almost at the end of the circle. That's almost